Welcome back to TIN 302 Engineering Economic Analysis with me, Ferry Afrinaldi. So, previously we discussed the present worth analysis when the useful life of the alternative equals the analysis period. On this video, we will discuss number 2 and number 3, which are the alternative have useful life different from the analysis period, and when we have an infinite analysis period. We will start from number 2, the useful life different from the analysis period. So in performing the present worth analysis, when the life of the alternative are different, so we must do the comparison over the same number of years. There are two things that we can do. Number one, compare the alternative over a period of time equal to the least common multiple or LCM for their life. So in bahasa Indonesia, LCM is KPK, kelipatan persekutuan kecil. And the second thing that we can do, we compare the alternative. We compare the alternative planning horizon using a planning horizon which does not take into consideration the life of the alternative. So with the first approach, for example, we have two machines that we will compare. The first machine has the life of 5 years and the second machine has the life of 10 years. So we will do the present worth analysis over a period of 10 years because the LCM of 5 and 10 is 10. Or we can do the analysis by using a planning horizon which does not take into consideration the life of the alternative. For example, we have machine 1 and that machine has the life of 8 years, and we have machine 2 and the life of that machine is 6 years. So we can do the present worth analysis for the planning horizon of 5 years, for example. So now uh, let's I will explain this example. So in this example, we try to decide between the machine below with the interest rate equals 15%. So we have machine A and the life of that machine is 6 years, and machine B and the life of that machine is 9 years. So we will do the first approach. So for this example, the first thing that we need to do is to calculate the LCM. The LCM of 6 and 9, and that's equal 18. So we will do the analysis for 18 years. So we will analyze machine A first. So we will have year 0, and then year 6, year 12 and year 18. So this is for machine A. Okay, so I'm gonna label this for machine A. So for the machine A, the first cost is 11,000, so that's a negative cash flow, so it will be over here. Okay, that's 11k. Okay, and then at the end of the 6 years, we're gonna have the salvage value of 10,000. So we're gonna have salvage value over here, and that's equal 1,000. The annual operating cost is 3,500. So we will have the operating cost starting from year 1 till the end of year 6. I'm sorry. Okay, and this is 3.5. Okay, but remember, this is the first machine. So at the end of year 6, we need to buy a new machine. So with the new machine, so we're gonna have a cash flow, which is also 11k. And we need to pay for the operation and maintenance costs. Okay, let's start from year 1, no, year 7. Sorry, from year 7 over here until sorry, I have difficulty, until the year of 12. Okay, and at the end of year 12, for the first machine, we're gonna get salvage value for 1k. Okay, and that's the end for machine number 2. So we need machine number 3, so we need to buy a new machine. That's gonna cost us 11,000. And for the new machine, for the third machine, we need to pay for the operation and maintenance costs. This is 3.5k. Just 3.5k. Okay, just 3.5k. And at the end of year 18, we're gonna get the salvage value of 1k. Okay, so this is the cash flow for machine A. So now we need to calculate the present worth for machine A. PW of A, and that's equal. So the first 11k, it is at year 0, so no need to do anything to it, so it's minus 11k. And then minus the operating and maintenance costs we paid every year from year 1 till the end of year 18. So that's an A, but we need to calculate the P, so it will be 3.5k times P over A, 15%, 18. Okay, and then for uh, the next 11K, so that's an F. So we need to calculate P, so it's P over F, 15% 6 minus 11K times, so this is for the third uh, machine, so will be P over F, 15% 12. Okay, and the last thing that we need to do is for the 1000. So we have 1000, but that's a positive cash flow, so it will be 1K times P over F, 15% 6. I'm just gonna copy. Okay, so it will be 12 over here plus and 18 over here. So the next thing that we need to do, we need to look up the interest table, and if you do this correctly, so the present worth of machine A is minus 38.559K. So that's the present worth of machine A. Now we need to calculate the present worth for machine B, and the analysis period will be 18 years. So we're gonna do for machine B, okay, so we're gonna do this for 11 years and for 18 years. Okay, so see, the life of machine B is 9 years, so we're gonna have 0, 8, no, 9, and then 18. So for this we gonna have two machines. Okay, so for the first machine, the initial cost is 18K, so we're gonna have 18K over here. Okay, so this is 18K, and the salvage value is 2000, so that's gonna happen at the end of year 9. It's 2K, and the operating and maintenance cost is 3.1K. So this is 3.1K. That's for the first machine. For the second machine, we need to buy the machine, so that's a negative cash flow, another 18K. We need to pay for the operating and maintenance costs starting from year 10 till the end of year 18. So that's equal 3.1k, and then we're gonna get the salvage value of the machine at the end of year 18, and that's equal to k. Now the present worth of machine B equals, so minus 18k, so that is for the 18k at year 0, and then minus 18k times this is for the second 18k, that will be P over F, 15%, 9, okay. And then plus 2k, the salvage value of the first machine, times P over F, 15%, 9, okay. Okay, something that I miss, which is the okay, I will calculate the O and M at the end. So I have 18k and 18k. Okay, I have 2k, and I will have another 2k times P over F, sorry, P over F, 15%, 18, and then minus 3.1k, that's the annual cost, and that happened from year 1 till the end of year 18. That will be P over A, 15%, 18. Okay, so if you look up the table and you do it correctly, then you're gonna have the present worth of machine B equal minus 41.384k. Okay, so because the present worth of machine A, which is minus 38.559, is bigger than the present worth of machine B, which is minus 41.38, so we choose machine A. Okay. Now let's take a look example 6. So for example 6, we will do present worth analysis for machine A and machine B that we have in example 5, but the planning horizon, it is just 5 years. Okay, so because it is just 5 years, so the cash flow will be like this. We're gonna have year 0 till year 5 for both machine. So this is for machine A, this is machine A. So for the machine A, the initial cost is 11k. So this is the initial cost, this is 11k, and the operating cost 3.5k. So will be 3.5k. So this is 3.5k and the salvage value of 1k. Okay. 1k. So this is the cash flow for machine A. If we decide to have a planning horizon of 5 years. So for machine B, so we will have year 0 till year 5. And for machine B, the first cost is 18k. So this will be 18k. This 18k. The salvage value is 2k. Okay. 2k. And the the operating cost is 3.1k. And this is for machine B. So I will give it to you to calculate the present worth for machine A and the present worth for machine B when we have a 5 years planning horizon. And you need to decide based on the calculation that you have which machine that is better. So that is the present worth analysis when we have useful life different from the analysis period. And the last thing for the present worth analysis, it is when we have the analysis period equals infinity. So especially in the governmental project, the service condition of the asset can be an infinite period. So for example, if we do an analysis for road, pipelines, bridges, so the analysis period will be infinity because sometimes we consider the road, the pipelines, the stadium to be permanent. So for the infinite analysis period, so we need to apply the concept of the capitalized cost. So this is an example that illustrate the concept of the capitalized cost. Suppose that you deposit $200 in a bank, and that bank pay the interest of 4% every year, and then how much money could be withdrawn each year without reducing the balance in the account below in sorry, how much money could be withdrawn each year without reducing the balance in the account below the initial $200? So the answer to that question should be easy. So the amount of money every year that you can take from your deposit every year is A, and that will equal 200 over 200 times 0.04 or $80. So you can take $80 every year from your account, and still the balance of your account will be 200. Because what? Because the $80, it is just the interest that the bank pays you. So you just take the interest every year, and your balance will still will be $200. Okay, and the the $200. So this is the $200, the amount of money that stays in your account, that what we call as the capitalized cost. Okay, so if you have if we do an analysis for a stadium, for example, and the maintenance cost of that stadium is 80 million per year, then the capitalized cost means how much money that we should put in a bank, or how much money that we need to to deposit in a bank if that bank pay 4% interest rate per year. So how much money that we need to put in that bank so that every year we can take 80 million from our account without reducing the balance of of our account with respect to the amount of money that we pay at the beginning. And the answer should be the 80 million over 0.04, and that will be 200 million. So the 200 million is the capitalized cost. So the equation to calculate the capitalized cost and the level of the notation for the capitalized cost is P, and that P is A over I, where I is the interest rate per year. So why the capitalized cost is P? Because it refers to the amount of money that we need to put in the bank now in order to have some money that we can withdraw every year from from that bank, and that amount of money that we can take from that bank every year equals the amount of the interest that the bank pays us. So that's the capitalized cost. Now let's solve let's see an example of how we calculate the capitalized cost. Now there is a city, and in that city there's a pipeline to transport water from a distant area to the city. The pipeline will cost 8 million and it will have an expected life of 70 years. The city expects to keep the water line in service indefinitely. So this is the keyword, indefinitely. That's mean the end or the analysis period equals infinity. Compute the capitalized cost assuming 7% interest. So the life of that pipeline is 70 years, but our analysis period is infinite. Okay, so we have year 0, year 70, year 140, and then year 210. Okay, and so on till infinity. Okay, so the cost of the pipeline is 8 million, so we have that in year 0. So this is 8 million. And after 70 years we need to get a new pipeline. So the cost also 8 million. Okay, so in the year of 140 we need another 8 million. And this will happen forever. So we need to calculate the capitalized cost. So the first thing that we need to do is that we need to calculate the capitalized cost. So we need to calculate P. Okay. Okay. So the thing that we need to do is that we need to convert the 8 million into A. Okay. So the A will be, because this 8 million is a present value, so we have 8 millions, sorry, 8 millions times, so should be A over P. So the interest rate is 7% per year, and the life is 70 years, and the result will be 0.565 million. So that will be like this. So I will use a different color. Okay. So this is the 0.565, and remember the 0.565 is the 8 million that you convert into an A. And the same thing we will do the same thing for the second 8 million. We will do the same thing for the third 8 million, for the fourth 8 million, and we'll do this forever. So what we're gonna have 0.565 every year forever. So now, since we have A every year forever, then we can calculate P, the capitalized cost. Okay, capitalized cost, that's equal P, and that's equal A over I, and that should be 0.565 M over 0.07, and that equals 8 8.071 millions. So that's the capitalized cost of the uh, pipeline system for that city. I think that is all for this video, and thank you very much.